Different types of lines used in engineering drawing. These are the different lines used in engineering drawing. First, continuous thick, which is approximately 0.5 to 0.6 millimeter thick. Such lines are used for drawing visible outlines, visible edges. We have a machine part here, and we can see all the edges or outlines are drawn using continuous thick line. Second one is continuous thin, which is approximately 0.3 millimeter thick. Such lines are used for drawing projection lines, dimension lines, imaginary lines of intersections, leader lines. In this figure, we have a front view and a top view. Here we can see some of the lines are very faint and some lines are dark. These outlines, which we have already seen, are continuous thick line, whereas continuous thin line are used for drawing projection line. These are projection line. Projection lines are projecting any lines from one view to another view. These lines are little faint as compared to continuous thick. Then these are dimension lines. Dimension lines are also drawn by using continuous thin lines. Third one is dash thick. It is approximately 0.35 to 0.45 millimeter. And the fourth one is dashed thin. Again, it is approximately 0.35 to 0.45 millimeter. These two lines are used to draw hidden lines and hidden edges. In this machine component, we can see there is a hole present here and a slot present here. When we look from the side view, this slot is hidden. Whereas when we look from the top view, this hole is hidden. So anything hidden is shown as dotted lines or dashed lines. So this hole, when it is projected for side view, it is shown as dashed thin. And the slot, which is not visible from the side view, the slot is also shown here as dashed thin line. Then number 5 is chain thin line, which is approximately 0.3 millimeter thick, and it is drawn as a long dash and a small dash alternate. It is used to draw center line and line of symmetry. Here in this example, we see a circle is drawn and a vertical center line and a horizontal center line is drawn by using chain thin line. Then again, in this diagram, we have a cylindrical part which looks a rectangle in front view and circle in side view. So we have drawn the axis of symmetry here by using chain thin line. Then line number 6, long chain and thick at ends with a thickness of approximately 0.6 to 0.8 millimeter. It is drawn similar to chain thin line, a long line and a small dash alternate, and at the ends the line is thicker. Such a line is used to draw cutting plane line or section plane line. In this drawing, we can see We have used a cutting plane line to cut this machine part into two pieces. This is a representation of long chain and thick at ends. Then number 7, continuous thin zigzag line. It is used to draw long break lines with a thickness of approximately 0.5 to 0.6 millimeter. You can see here a long break line is shown here.
We will practice some geometrical constructions. Draw a rectangle 60 mm by 40 mm. Here I have shown an example of a rectangle ABCD with side 60 mm and 40 mm. So we will start by drawing a straight line AB 60 mm. Side AB 60 mm. Then we know that these two sides are perpendicular to each other. So from point B we will draw a vertical line by using protractor. Mark the center of this protractor with point B, and the straight line AB should overlap with this reference line. Measure 90° here and draw a vertical line. Then side BC is 40 mm. Measure 40 mm from point B and draw the vertical line. So we get point C. Now by using ruler scale we will draw these two lines. Match the ruler scale with side AB and slide it till it reaches point C and draw a straight line. This line is parallel to side AB. Then match the ruler scale with side BC and slide it till it reaches point A and draw a vertical line from point A. The point where these two lines intersect, we get the last point, point D. Connecting these two lines, we get the rectangle. Now we can give the dimensions. Project a straight line from AD and BC. Now draw a line parallel to side AB to draw dimension line. Similarly, project a line from side AB and from side CD and draw a line parallel to side BC to get dimension line. We can note here 40 millimeter and 60 millimeter. Draw a circle diameter 60 millimeter. Here I have shown a circle with diameter AB 60 millimeter, center O. So from center O till A will be the radius 30 millimeter, and from A to B will be diameter 60 millimeter. Now by using a compass we will draw a circle taking radius 30 millimeter, that is half of diameter 60 mm. Take measurement 30 millimeter, placing the compass needle on 0 point of scale. Take radius 30 millimeter and draw a circle. Firmly place the compass needle on the drawing sheet and draw a circle by rotating this compass. Now we need to note the dimension 60 millimeter. For giving dimension, we should never draw a horizontal line or a vertical dimension line. The dimension line within the circle should be an inclined line. From the center, we draw the diagonal, and this will be the dimension line. And we note here diameter 60 millimeter. We will draw a regular pentagon of side 40 millimeter. Here I have shown a pentagon with side AB, BC, CD and DE. A pentagon has 5 sides and all sides are inclined at 108 degree. So let's draw side AB 40 millimeter. Draw a straight line we know that the inclination is 108 degree. Using a protractor, place the center of this protractor on point A such that this horizontal line must overlap side AB. Now measure inclination 108 degree. This is 90, 100, 105, 6, 7, 8. Mark a point here and connect measure 40 millimeter and we get point E. Similarly, for point C, we will use this angle 108 degree. Place the center of this protractor on point B such that this horizontal line should match side AB. Now in clockwise direction measure 108 degree. Connect this point with B and measure 40 millimeter. And here we get point C. Now to get point D, we can use a compass, measure 40 millimeter. We get 40 millimeter here. Place the compass needle on point E and cut an arc. Then place the compass needle on point C and cut another arc. We get point D. We get point D. Connecting these points together, we get a regular pentagon. Now we need to give dimension. 40 millimeter. Project a line from point A and B. Draw a line parallel to AB for dimension line. Mark the inclination. Draw a regular hexagon of side 35 millimeter. A regular hexagon has 6 sides and all sides are equal, and it has an inclination of 120 degree. Here in this hexagon, if we connect all the opposite corners together, we get the center of the hexagon, and using this center we can draw a circle such that the circle will touch all the 6 points. So we will draw a hexagon by using a circle method. Mark center O. So here we can see that side AB is equal to BO and it is also equal to AO. So we get number of equilateral triangles. So by using this circle method we can draw a hexagon, and here we get to know that the radius of the circle is equal to the side of the hexagon. So while drawing a hexagon we will use side 35 millimeter as the radius of the circle. Taking radius 35 millimeter, draw a circle. Then we draw a horizontal line passing through the center of the circle. By drawing this horizontal line, we get 2 points, point F and point C. Now take the same radius 35 millimeter, place the compass needle on point F and cut an arc on the circle both the sides. Then place the compass needle on point C and cut arc on both the sides of the circle. These arcs will give point A, B, we already have C, and point D and point E. Connecting all these 6 points together by straight lines, we get a regular hexagon. Now we can give dimension, side 35 millimeter. Project lines from point A and B. Draw the dimension line parallel to side AB. Also mark the inclination. Let's take a question. Draw a straight line 97 millimeter long and divide it into 10 equal parts. For this, first we need to draw a straight line 97 millimeter long. Let's name this line AB. To divide line AB into 10 equal parts, we will draw a straight line from point A at any inclination. Now we will mark 10 equidistant points on this line. Let's take 10 points all equidistant at 1 centimeter each. We can also cut 10 number of arcs at equidistance using a compass. Now name these points 1 dash, 2 dash, 3 dash and so on. Next step, we will connect point 10 dash with the end point of this line B. This line should be faint. Now we will use a ruler scale. Match the ruler scale with line 10 dash B and slide the scale till it reaches 9 dash, and from this point draw a line. This line is parallel to 10 dash B. Then slide it again till 8 dash and extend a line till it reaches line AB. Continue this procedure from 7 dash, then a line from 6 dash, from 5 dash, and finally from 1 dash. So we can see that from 1 dash till 10 dash we have projected number of lines on line AB, and this line AB has been divided into 10 number of parts. We can name these points. A projection line from 1 dash we get here point number 1, then 2, 3, so we can see that this line AB has been divided into 10 number of equal parts. Now we can give dimension. Project a line from A and from point B and note the dimension.